Okay, hello. First of all, I'm very happy to be here, having gone to undergraduate at this institution. It's very nice to be back as a proud Hoosier. And I'm visiting today from Duke Sociology. My name is Joshua Doyle. And what I'm going to present today are early results from a project that Susan Jacobs, Steve Vaisey, and Achim Edelmann and I are working on, or have been working on for the past few months. So I'm looking forward to hearing what you all think about it. So in the past few years, a number of word embedding models have been developed for large-scale textual analysis. Word2Vec is one of the more popular word embedding models that takes a large corpus of text and assigns each word in that corpus a position in a continuous vector space based on the context that word shares with other words in the corpus. Words that share similar contexts in the corpus are located close to one another in the vector space recovered by the algorithm, while words that don't share similar context are located further apart in that vector space. What we wondered was if we were to take a massive corpus of text representing public culture as public discourse, how well would the vector positions of words taken from ACT dictionaries recovered by the Word2Vec model predict the position of the same term in EPA space created by human raters in ACT dictionaries? If the early results of these analyses were promising, we hope that there might be potential to use word embedding algorithms to assign EPA ratings to more words than are in the dictionaries, and even to observe changes in ratings over time in large corpuses of public discourse without having to rely entirely on human raters. The ACT dictionaries we used to draw the EPA ratings from were the UGA, Duke, and MTurk dictionaries. And the basis of the Word2Vec model that we used was the corpus of contemporary American English as the input for the Word2Vec model, which is a genre-based corpus of approximately 560 million words from various sources from the years 1997 to 2017. So in our analysis, I'm going to use the example of how we got the analyses for evaluation. We first get the vector positions for all the words in the corpus, and then take the distance in this space, in this case for evaluation, between the terms good and bad. Then we take the correlation of this difference with the vector score of each term in the ACT dictionaries that's in the contemporary English corpus. This gives us how close that particular term is to the position of the term good in the case of evaluation, powerful in the case of potency, and lively in the case for activity. Then we use this correlation to predict the evaluation, potency, and activity ratings from the ACT dictionaries. This graph plots the correlation of the vector position of each ACT term to the distance between good and bad for evaluation, powerful and weak for potency, and lively and still for activity on the x-axis. And on the y-axis are the EPA ratings from the ACT dictionaries. The purple line represents the relationship between these two as the locally weighted regressions for evaluation in purple, red for potency, and light blue for activity. For the evaluation scores from the Word2Vec model accounts for 15% of the variance from the ACT dictionaries for evaluation. So for example, terms from the Word2Vec model placed further from the position assigned to good were terms like evil and idiot, while closer to good were friendly and welcome. For potency, the scores from the Word2Vec model accounted for 9% of the variance in the ACT ratings, and the terms assigned closer to powerful in the vector space were words like strong and superstar, and further away, helpless and powerless. And for activity, the Word2Vec model scores predicted 10% of the variance in the ACT ratings, and terms closer in the vector space to lively were terms like active and noisy, and further away were examples were loner and calm. So what we've done so far, we consider early steps, and the R-squareds are not terribly high, but we do want to keep adjusting the parameters of the Word2Vec model since we think the findings so far are promising. Thank you.